Okay, thank you, and good afternoon, ladies and gentlemen, and thanks for the organizer to give us this opportunity to introduce our China State Grid project, and also my colleague just already mentioned the importance of this energy storage station, and already introduced a kind of a brief about what is the energy storage station. So before I started, actually, I want to have an announcement of our company also have a conference, business conference and a cocktail meeting in the afternoon of 10th from 3 p.m. to 5:30. We will announce our new product and new distribution policy for this energy storage station in Italy. So we will be welcome you to be there. The location would be the B4 Hotel near the exhibition hall. Okay, let's start it. So my presentation today would be having the 5 parts, 1 page of the BYD complete brief, and then 3 slides of the home-based energy storage system. Particularly, it's good solution for the Italy and Germany right now. And then utility-scale energy storage station. Then after that, we're going to focus on the China State Grid project and the Southern Grid project. So BYD, as the chairman just mentioned, stands for Build Your Dreams, and we have 4 R&D centers, including the 15,000 engineers, to support our 3 business groups: transportation, new energy, and the consumer electronics. So the transportation area, we are the 6th largest automaker in China and the largest local brand in China. And we're also in a leading position with electrical vehicle, electrical bus, and electrical forklift. So in the new energy area, we actually are starting our business in 1995 with a battery business. And today we are world's largest mobile phone battery supplier in the world with 25% market share. And also we are having 1 gigawatt solar panel production with fully automatically production. Actually, we have a big event in SNEC in this month as well in Shanghai. So the third area is our cutting edge of the iron phosphate battery for the utility-scale energy storage station and also the electrical vehicle. So LED lighting from the consumption side is also another area we are having a larger production quantity. So in this segment, actually, we are fully vertical integrated from the generation to storage till the consumption. So the consumer electronics field, we actually are number 2 biggest cell phone components producer in the world, and we supply for the Motorola, Nokia, and on Apple, Google, this kind of brand news. So also we are having the 1/3 of this Nokia mobile phone components are actually produced by BYD. So talking about the energy storage station, and we actually have the 2 solutions, the utility scale energy storage station and then the home-based energy storage station. So the utility scale energy storage station actually having 2 types, the stationary type and the transported type. So besides that, the electrical vehicle also play an important role in the night to storage the electricity. And if its resources is not enough, we can add the battery storage to balance the grid as well. So here is a technology of the home-based battery, which BYD design and production today, and including the new installation and then existing PV rooftop system. In the left side, actually, is a new installation. The battery can directly connect it to the solar charge from the DC side, and then through the converter supply to the grid and the load. And the existing rooftop system, to reduce your job, and we actually put the battery and the converter as a module, so directly connected to the grid and supply the load from the AC side. So these both solutions are now commercialized, and we designed from the 3 kilowatt to 9 kilowatt systems to supply the Germany and Italy market. Actually, it's on the way to the grid parity, which we are talking about today. So here is roughly a calculation about the IRR, and you're taking a single family in Germany about install 4 kilowatt PV system with a 3 kilowatt inverter with 8 kilowatt hour battery system as the example. So bank will be provided the 3% of the fixed rate with 15 years. So cost of energy annually increase with 5%, which everybody agreed. So the power loss of the PV module assumed 0.3% per year. So based on this calculation assumption, so you will need to spend 100 euros per month to the bank, and the totally expend would be around 17,000 euro. And the benefit you will be getting is around 39,000. So the return of the investment period is around 10 years in Germany right now, based on our solution. So the IRR is around like 8.9%. But in Italy, this number now can be much greater because we have a little bit, subsidy for the storage as well. So the large utility-scale energy storage system, we are already being adopted by the major industry. Here is parts of the example we are doing. The latest one actually was the Chevron microgrid system with 2 megawatt, 4 megawatt hour, and the largest one so far in the world about the China State Grid with 6 megawatt, 36 megawatt hour, and the China Southern Grid. So the Chevron project installed in San Francisco was finished actually last October, but they're commercialized operated last month. So the efficiency is around 91%. And according to the Chevron's own calculation, this microgrid system can reduce around $100,000 per year for the utility bill for the city. So the State Grid project, you can see the right side of the picture. That is a site which installed this 36 megawatt hour battery inside. So the background of this project actually is that the China northern side have a lot of wind resources, and as a generation company, they installed a lot of the energy, the wind farm there. But the problem is that the instability about supply this one to the grid. So actually, they connected to the grid is actually a very small number. So when they came to us and asked for a solution, we proposed about the iron phosphate battery energy storage system. This is also a kind of a part of the Golden Sun program, which we mentioned yesterday. So the full cover about 3 soccer fields in length, including by 275 meter long with 45 meter to 50 meter widest. So the topology of this system, actually the storage are putting together with a 100 megawatt wind farm with a 40 megawatt PV system, and our 36 megawatt hour, 6 megawatt, actually the part of the 20 megawatt storage together. So this system actually connected to the 220 kV smart substation. And the important things here also, you will see the bottom picture here. They built a very smart panoramic intelligence system to monitoring and to utilize a 3 system, and also according to the dispatch schedule. But also they can seamlessly transit from one to another. So the major parameter here, the 36 megawatt actually divided by 3 units, and each unit 2 megawatt with a 12 megawatt hour. So the China State Grid actually they required about 1.5 power rate. So we added around 18 sets of the BYD own designed 500 kilowatt PCS, and the whole project actually are finished by 2011. So the advantage about this system, actually my colleague also mentioned just now, it smooths the output from the wind and the solar output. Then it can be accepted by the state grid company, transmission company. And the second is peak shaving and fill the valley to also get another extra benefit from the west. So the third one is a participant in the frequency regulation. We're talking about is a 5 millisecond reaction time, and the urgency transient active power response, and the last one is urgency voltage supporting as well. So the topology of the whole system, the battery, actually we are having around 68,000 pieces of the 200 ampere hour battery system here, and each battery have the battery management system to support, and also to going through the 500 kW PCS through the transformer to supply the grid. So this is the core components we're talking about. It is an iron phosphate battery, and this is actually a deep cycle battery with around at least 6,000 cycles. So generally say if we're discharging per day, it means you can run it around 20 years. So the high energy density, and this one is only a little bit lower than the lithium-ion battery, but it's higher than these other technology as well. So the good performance in the high temperature, technical say it can be operated from the minus 20 degree to 60 degree. So also the safety is performance is excellency. So the BMS system, as I mentioned just now, is very key for the whole system as well. So that's why we recommend our customer and partner to think about it, to using the vertical integration solution to manage the whole system. Because of when you see the picture in the right side here, from the bottom to the top, so the BMS offering the 4 level of the protection for these batteries. From the cell level, it protects the temperature and the voltage. And the battery module level, it protects the over leakage and over current. So the third level is a battery unit when the communication to the whole system is failed, but this one can cut it off directly and run it independently. And the battery stack can run it independently through this BMS protection as well. So the PCS also designed and produced by ourselves. So this one is most suitable for our own battery, and having the 3 millisecond high volt right through, and also the average response time is around 5 milliseconds. And from the power factor, continuous regulation in all of the 4 current. So look at the schedule here we are doing for the China State Grid. Having received the PO from the June, and we spend around 6 months to finish the whole project, which is compared with traditionally power grid upgrade is a very short lead time. So the Southern Grid project actually is a background when the year of 2011, our city Shenzhen have a universite game, and the government projected that there will be a kind of electricity shortage from the supply to the demand around 16 megawatt hour. So they don't have enough time to build a new grid or to as a backup. So when they came to us and offering the solution to them about to finish in the 3 phases, they took around 8 months. So the inside and outside of picture here, and the system charging time is actually 4 hours in the middle night, and then discharge in the morning 2 hours and afternoon 2 hours. So to wrap up my topic here, actually the benefit about the energy storage station, even today for the largest scale of utility, we're still not see very great numbers, but you can see some roughly idea here from the left side is that the cost of the energy storage station. For this is an example for the China Southern Grid. And the other way for power line upgrade is the black one. So if you look at this data, the new energy storage stations are still higher than the existing old technology. But when you look at the peak saving and also plus this air emission benefit and reduce the water usage, and also for some this harmonic disposal reactive power compensative. So the most also important thing is that the short lead time to saving time. Time is money. Everybody knows it. So I think So by doing this one, so it depends on the different system characters. It will be also bring more value to our existing utility companies as well. So this is my finally page, and BYD today we already installed 165 megawatt batteries for the electrical vehicle energy storage station. So the electrical taxis, we have 300 taxis are running since May 2010. So totally traveled more than 6 million miles right now. And the 270 electrical bus has been introduced since 2011. Also traveled more than 1.8 million miles. So in the energy storage station field, we totally installed 70 megawatt hour so far. So last month and Lux research report, actually they give us a rank of the number 2 in the world for the installed grid-tied energy capacity. Okay, thank you for your attention, and we have an exhibition hall in Hall 7 as well. If you have any questions, you can contact my email address, and welcome to our exhibition and the cocktail meeting as well. Thank you.
Thank you very much, Mr. Luo. Also here, precise in time again.